Okay, so we are going to be doing the correction to the assignments I gave us last week. So I gave us some assignment on NumPy. We did NumPy last week, so we're going to just go over that, look at um, the corrections, and then move on to what we have for today. So today's class is actually not going to be very long. We'll try as much as we can to wrap up with NumPy. That is the agenda for today. That is what we have for today. So moving forward tomorrow, we'll move ahead to the other things on the curriculum, right? So let's move on with the correction. All right, so can please confirm if you can see my screen and if you can hear me clearly before I proceed. All right. Okay, so as I said before, that I pick an assignment from the assignment that I grade. If the assignment is good, I use it for correction. So it's a way of encouraging the person that has the assignment to keep it up, and also to also motivate us as well to do better. All right. So this is Peter Simfa Peter. You did well in your assignment. That is why you can see it up here. So you're going to be using your assignment to do the correction to the week 3 questions. All right, so let's just proceed. So basically we have 5 questions, unlike previous assignments we had. Okay, yeah, some of us, your assignment have not been graded. You will get everything before the end of today. Don't worry about that. You'll get your grade before the end of today. And as if you have any issue with the grading, you can always hit me up. So we have 5 questions today's assignment, unlike the previous assignment we've been given. So it's going to be a very quick one. So for the first question, I asked us to write a Python program using a for loop that iterates from 5 to 30 and add 2 to each number. So okay, there was someone that said something. I need to just reply that. Someone said I should be adding comments to the questions to the assignment. Now, the essence of this correction we are doing is to show you where exactly you missed it. Understand? Let me just tell you, I have up to 150 assignments submitted per week, 140 to 150. So giving specific corrections to everybody is not feasible at all. It is not feasible. Hence the need for general correction. So if you're here, you should be able to deduce from the correction where exactly you made the mistake and you correct yourself. Is that fine? Right. I would have loved to give tailored responses to each person, but that won't be feasible. Although that sometimes I see some particular things and I actually reply or send a message to that person. So that one is kind of different. But adding comments to each person's assignment is actually not feasible. So just know that. So this correction is meant to show you where you made a mistake and you can correct yourself. All right, so now this first question is using for loop. So we did for loop, we did function. So I've not tested you on that yet. So that is why you have this question. So the first question here, write a Python program using a for loop that iterates from 5 to 30 Now, some of us made mistakes in this particular question. So some of us, we did for I in range 5 to 30. Now, if you did this, just know you missed something. You will not get your full mark, right? I asked you to do from 5, between 5. You should generate numbers between 5 and 30, from 5 to 30 basically. So 30 should be included, right? So once you put 30 in this range here, you know what will happen. It will not get you the last number, which is 30. So for you to get 30, you have to add 1 to it, so making it 31. So this is basically what you need to do here. I said it in the last class, right? So, but some of us, I think, we missed that and we kept adding 30 here. So that was one thing I observed. And the other one was that some persons, I don't know if they didn't understand the question completely. They did 5, added 30, and then added another number 2 here. So this is not is a correct code, right? But it does not answer this question here. So what exactly does this particular code do? This range 532. So can someone just tell me what this code here would do in the group chat? Exactly, exactly. It's increment each step by 2, right? It does not add 2 to each element or each number in the sequence. So this is wrong. This is wrong too. So the right answer is for I in range 5 and then 31, right? You can as well come here and put 1. 1 is the same thing as not even putting anything there, right? So it's just to help you understand the whole thing. And then you would add the each element in the sequence, you add 2 to it and then print the result. I love how this person used string formatting to print out the result. Understand? So this, whenever I see this, I'm always happy because yeah, you are using what we've learned already to answer the question. So you can see basically it just prints out the entire thing and shows us the result when we add 2 to it. So you can just, this is just, if you did this, fine, you are going to get your mark, right? So this is the answer to the first question. So the second question here, given a variable x equals to 5, write a Python program using the while loop that checks if x is less than or equals to 55 and increment x by 5 if true. So, when it comes to this kind of question, you should actually take your time to understand the question or break it down, right? So, when you're given a question that involves you to program, the best approach is to break the questions into bits and answer it one by one, right? So you are going to get the core idea or the main idea in the question. You understand? So in this question, the first statement, giving a variable x equals to 5. Okay, there's a variable we are given, right? Then I'll initialize that variable here. Write a Python program using a while loop that checks that this is the second one that checks if x is less than or equal to 55. Then you come here and write start your while loop here condition y x less than or equal to 55 and increment x by 5 if true. So basically you just put the increment statement below that, and that's it. Basically, that is just it. So you allow the while loop to do its thing. So you can either print the there is no specific position to print the value, right? But if you included the print value up here or after, then it's fine. Yeah, some persons included it here and also included it down and specified, okay, this was before adding 5 and this is after adding 5. That is beautiful. Understand? I when I saw it, I loved it. So you can just try as much as you can to be creative with your answers. Don't go beyond what was asked, but try to use what we've learned to embellish or to make your answer more presentable, right? So you can see this answers it. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So you basically add 5 to each of the numbers. So when it got to 55, 55 was now compared with this 55 and it gave us false. So the loop stopped at that point. You understand? Remember how while loops work. While loops are only executed when what? So what is the criteria for the execution of a while loop? Can someone just quickly answer that in the group chat? What's the criteria for the execution of a while loop? Someone said false. No, no, no. It's true. Okay, okay. I think that should be a mistake. Yeah, when the condition above is true, then your while loop will be executed. But once that condition amounts to false, then your while loop will stop executing. It's as simple as that, right? So that is the second question. As you can see, these questions are very easy and straightforward. If you attended the class last week, you won't have an issue with it. So the next question, number 3, the question that most people failed. A lot of us failed this question. We didn't get this question. So we didn't get it right basically. So let's just look at how we answer that. So question 3 is that we should write a function in Python that accepts a list. Now, as I said, break down the questions into several parts. Okay, the first part, write a function. You can see that part, write a function, all right, that accepts a list of integers, right, and returns a NumPy array containing this integers. So what I'm asking here is basically to define a function, a user-defined function, right, that accepts a list of integers and return an array, a NumPy array containing these integers. So how we do that basically, you obviously have to import your NumPy library. Now, how do you define function again? You use your def function, def, and you can name your function whatever it is you want to name it. So in this case, this person named it list to NumPy array. Your function would have a parameter because it is taking in what we said here, that your function will accept a list of integers. So you can just put the parameter that will be the list of integers here, right? And return a NumPy array containing this integer. So the next what we have under the function, you can just simply just return this, right? Return np.array, taking in this list that we are going to be passing in here, and then you're going to get a transformed integer into an array. So this person did it directly, right? So, but to help you understand it better, you can just do like this, numpy list. You assign it to this, and then you say return numpy list, right? So you can do it this way. So you just whatever way you want to do it, but that other way is quite straightforward. So once you do that, you can now, in any part of your notebook, you can now initialize a list that contains integers, right? And then assign it to a variable, and then assign that variable to the function that we have here. So now you see the importance of using return statement, right? If you didn't have return statement here, you will not be able to assign the output of your list of your function to a variable. You understand? So let me just quickly show us here. If I say print NumPy list, if I remove the return statement and put print, and I come here and say list NumPy array, and then put our integer, and I assign it to a variable, and I print that variable, what output am I going to get here from the result array? What output am I going to get based on what we said last week? I explained the importance of return statement, so I expect us to um to know what we are supposed to be seeing. Only one person is saying something. Okay. Maybe we might have forgotten. But basically, um, we're going to have I don't know if this is going to run. You are going to have none. Can you see it here? None, basically. So let me even remove print self. So now print it. We're going to have none, right? Because we are not returning anything. Understand? So just this is just to show the importance of the return statement. I said this in the last class. So that is why we have the return here. So if you say return numpy list, see instead of having none, we are going to have the values here, right? So to be returning the this particular list, then this entire function output is going to be this returned data here, and it will now be passed into this variable here that we can now print out. So that is basically what happens there. So this is what I expected for this question 3. But some of us, what we're doing is we just came here and said np.array, and we put our list here, and that was it. Like this is not what I wanted you to do. You are just basically calling the np function, the array function directly. I needed you to define a function, right, that will do that. Understand? So I understand that this is, you can do it like this, but no, I was just testing your knowledge on defining functions. So I combine it with NumPy that we did. So if you did it this way, you can now see where you missed it. You understand? So this was what I expected from that particular um, question. So that's it for question 3. So question 4, right? It's also straightforward. The question is demonstrate how to create a one-dimensional, two-dimensional, and three-dimensional NumPy arrays using np.array. Use any suitable data for the arrays and display each. The one-dimensional, two-dimensional, and three-dimensional arrays you created should have shapes of, you see, I specified the shapes here. So on your own, you can just use anything it is that you want to, any number basically, and just make sure that they align with these shapes that are given here. So based on what we did last week, you can actually define those, and also print the shapes of each array. So when I get the output, I should be saying the one dimension is 7, two dimensional is 4 by 4, three dimensional is 3 by 2 by 3. So that's it. Yes, you have remarked. So question 5 is that 3 questions in one. So the first is write a Python code to create 2 arrays using np.0s and np.1 with a shape of 4 by 5. Print both arrays. Question 2, using np a range function, create an array from 10 to 36. So this one, some persons still didn't missed it here. And the last one, using np.linspace, generate number between 20 and 50. 25 linearly spaced values. So for the first question, that is pretty straightforward. You just specify the shape here using np.zeros, right? 4 by 5, np.1s, the same thing, 4 by 5. So I should be seeing this output here. The second question, um, now, when I ask you to create something from a number to a number, you know by default that Python will not include that last number. If you included 36 here, Python will not include 36 to stop at 35. So for you to include 36 in the output, you need to add 1 to it, so making it 37. So you will now have this correct output that I need from you, which is from 10 to 36. All right. So that is it for the second question. And for the third question, using linspace, you know how to do this. So basically, the linspace function will just help you create numbers in between two range, in between in a range, right? In this case, between 20 and 50, you need 25 values. So to do that for you, that is it. You can see that these questions are actually easy and straightforward. There is actually not much to say. If you attended the last class, if you went over the video that we did and all of that, you're going to have this question to be easy, right? So that's going to be it for the correction. um so yeah, are we following? And can everyone still hear me? Please let me know, because we're going to be going straight to what we have for today. Can everyone still hear me and see my screen? All right, so today we are going to be continuing from where we stopped last week. So last week we stopped at attributes of arrays, right? This was where we stopped last week. So today we are going to be continuing from there. We're going to be looking at how to slice and index arrays, right? We're going to look at that. We're going to also look at basic operations in NumPy. We're going to look at element-wise operation. We're going to look at array broadcasting. We're going to look at vectorization. And then we are also going to just basically look at array manipulation, so where we can manipulate our arrays, and also aggregation function. So hopefully we wrap up with all this today. Right, so let's start with that. So last week we introduced NumPy. I introduced NumPy to us. I told us what NumPy is, what it is used for, and the core data type in NumPy, which is what? An array, right? So I introduced all that to us. And I also showed us how to create arrays using different methods, right? So you can create an array using the np.array function, right? We can create using other functions like np.zeros, np.ones, arrange, and linspace, which was in your assignment. So by now you should know how to do all of that. So I showed us how to do that, creating an array. I also showed us how to access different attributes of our array. So once you create your array, you can actually know some things about your array by using these different methods, right? You can see shape, that is np.shape. We can see array.shape. You can see d type, size, and dim. There's a number of dimensions. So these are the basic things that you'll be doing most of the time when you want to understand the properties of your array. All right, so today we're going to be continuing from there and looking at how to access elements and slicing arrays. So this is not a new thing to you. We've looked at when we looked at list, Python list, I showed us how to index elements from a Python list. It was straightforward, right? It was actually very straightforward. So, but today we are going to be expanding that into arrays. So, how can we index arrays? So, let's just move on to our explanation sheet here. All right, so now remember we have different types of arrays. We have one-dimensional arrays, we have two-dimensional arrays, we have three-dimensional arrays, right? So these different arrays, they have different. You don't access the elements the same way. So when we come to the one-dimensional array, well, let's just create one. All right, so if I run this code, I'm going to get an error. Can someone point out the problem with this particular code here? Can someone tell me what the problem is with this code here? Because if I run it, I'm going to get an error. Exactly. So we have to import NumPy, right? So we'll come here and importing libraries. So we'll come and say import NumPy as np, right? So basically, we import NumPy. We're going to get the code will run without any hiccup, right? So now, how do we slicing the array or indexing basically? Anyone you want to use. So how do we slice one-dimensional array? It's the same idea with slicing your list, right? Anything that you learn doing slicing of list or indexing list is the same thing here in array one dimension, in one-dimensional array. So when you now start to use different approaches, when we now move further to the two-dimensional and the three-dimensional arrays. But for the one-dimensional array, the idea and the concept remains the same. So if I want to get from 4 to 6, what based on what we've done in list indexing, how am I going to grab that particular portion? If I want to get just 4, 5, 6 from this particular array now, what code will I write? I expect some answers from this. Okay. Someone said 3, 4, 5. What happened to 3, 4, 5? We should just write 3, 4, 5, or what exactly? Okay, as I said, array 1D, then 3 to 5. Okay, let's try that. So array 1D, 3 to 5. Before I run this, is this code correct? Is it going to give us from 4 to 6 here? Do we agree with this particular code here? Array 1D from 3 to 5. Is it correct? Should we go with it? Okay, someone is saying no. Okay, from 2 to 5. Okay, someone said from 2 to 5, not 3 to 5. Okay, let's change it. 2 to 5. Okay, is this going to give us those values? Okay, let's try that. Okay, so we're going to do this. All right, you can see that we are getting 4, 5, 6, right? That's basically it. That's how we index from a one-dimensional array. Very, very straightforward, right? Very, very straightforward. So you can just say if you want to like get the values from the second index to the last index, you just put 2 and not put anything at the end, right? So that's actually it. So I won't dwell much on the one-dimensional array. So let's just move on to the two-dimensional array because we've already looked at doing this one when we talked about lists, right? So let's move ahead. Slicing from a two-dimensional array. So this is when it now becomes not so straightforward. So I'm going to create an array 2D. And I'll say np.array. Someone asked if we have to import np in every cell. No, you just import it at the beginning of your code, and then you can use it anywhere, right, in that same notebook. So in this case, we're going to create new arrays, right? Come here, go to the next page, say 2, 8, 9. Let's add more values, right? So says, all right. So this is a two-dimensional array, right? If we print the array shape, we're going to see it is 3 by 5 array. It has 3 rows and what 5 columns. We've talked about this, so you should start getting familiar with this rows and column thing because it's something you're going to need to understand going forward. So now let's assume we want to slice okay, let's come here and say 2D. So let's assume we want to slice this particular element here, 4. So this 4 now is sitting on a row and what? A column. So which row is 4 in and which column is 4 in? Okay, let me get answers quickly. Which row is 4 in and which column is 4 in? Which row and column is 4 on, or in rather, in this particular array? Someone said row 1 colon what 2. Is this correct? So someone said row 1 colon 2. If we do row 1 colon 2, it will give us 9. Which is what is 9? This is 9 here. Someone said row 0 colon 1. Exactly. So if that is correct. So basically, to index 4, you have to include both the row and what the column. Understand? You have to include both the row and column. So that is for a single element. To get a single element, you have to specify the row where that element is, and the colon where that element is. All right, that's basically how you index a two-dimensional array. So in this case now, if I want to get this particular 3 here, what code am I going to use? How am I going to index it? So the 3 that I highlight now, how am I going to index it using the same logic? Please, I need quick answers, quick answers. Okay, row 2 colon 3. All right, you are correct. So that's basically how you index an element from a two-dimensional array. But what about if you want to index a particular row? So if you want to index a particular row, how do you do that? So in this case, if I want to index the first row, which is this, I can just come here and say 2. Just put 2. You understand? Remember, if it was a one-dimensional array and I put just 2 here, it is going to give me 4, just 4 in this case. But in this particular two-dimensional array, if I put 2 here, it's going to output the second index of my row. Understand? It's going to give me the second index. So if I come here and run this, you can see it's giving me the third column, which is the second index, right? So in two-dimensional array, the first row is the 0 index, second row is the first index, and third row is the third index. So basically the same concept. So if I come here, this is the 0 index, this one is the first index. Okay, let me say index 1. Come here and say index 0, and come here and say index 2, right? So you have an idea of what you're doing here. So that's basically it. And if I want to index the first row, I'll just say 0, and I'm going to get this. Understand? So if I come and say 0 to 1, I can get 0 to 2. I'm going to get the first row, right, till the second row, which is index 2. Remember, Python always doesn't include the last number here, which it still doesn't make sense, right? It's not intuitive, but just know that that's how Python works. If I say index 0 to 2, what I'm trying to tell it is that give me the 0th index till the index before this second index here. So it's just going to output just 2 rows for me in this case. Understand? So that's basically let's just add a new row here just to expand this stuff. Come here and say 4, 4, 3, 2, 6, right? So this is index 2. Yes, index 3. So if I say index 0 to 3, I'm going to get this, right? It's going to give me the 1, 2, 3, 3 rows basically from 0 to the second index. But if I don't put anything here, it's going to just output every single thing for me, right? So if I see this, you see, basically this is another way of indexing. Now, in two-dimensional array, once you put comma, the thing that follows it refers to the column aspect, right? The first number is always the row, understand? While the second number is always the column. That's basically how you index in two-dimensional array. Remember when we did 0 and 1, you're basically indexing just a single value. But if I come here and say 0, let's say in this case How will I put it? Okay, let me say I want to index all rows from column 1. This is basically how I'm going to do it. So this 0 colon refers to index all the values from this first row to the last row, and then index all the values from the second column. Understand? So if I print this out, I'm going to get this. It's going to return a row for me, which is equivalent to this row that I'm having here: 4, 8, 6, and 4. Why is it giving me this particular column? Because I indicated 1 here. Understand? If I change this 1 to 2, I'm going to get this second column, which is 5, 9, 4, and 3. Understand? What if I did the same thing like this? I added colon here. This colon meaning index everything from the second or from the third row, colon to the last colon. So I'll be getting everything from 5 to the last column that we have here. So 5, 3, 2, 9, 4, 2, 4, 3, 2, 3, 2, 6. You can see that this indexing is now becoming kind of complex because of the dimension. It was straightforward initially when we were doing the one-dimensional array, but in this two-dimensional array, you have to pay attention to the rows and column, right? So, but one thing you need to know, you need to understand how to index normally and pay attention to what you're indexing. The first value on the other side, on the left-hand side of your comma, refers to your row, while the second value on the right-hand side of your comma refers to colon. So you can now start specifying where and where you want to index as pertaining to the rows and the column. So let me just ask a question generally to know if everyone is following. All right. So let's say I want to index this 8 and 9. I want to index 8, 9, and 6, 4. 8, 9, and 6, 4. How am I going to do that? What code will I write, or what values will I put in this bracket here? So that's just, I'll give you a few seconds to think about that. I want to index 8, 9, and 6, 4. How am I going to approach that now with what we've just said? Eight, 9, and 6, 4. One says 0, 2, 1, 3. Okay. Row 1, 2. Okay, I'm still waiting for other answers before I proceed. All right. All right. So we're going to look at some of the responses here because you're the one answering this question now. I'm trying to make this class as interactive as possible. So I'm not just teaching, you are also learning at the same time. All right. So someone said, let's look at the Dolapo 0, 2. He said 0, 2, and what? 1, 3. So let's see what it's going to give us. So you can see what it gave us. It gave us 4, 5, and 8, 9. That is not what we want. It gave us this 4, 5, and 8, 9. That's not what we want, right? So that is not correct. So let's look at the second one. We have Adeyemi. That is row 1. That is 1 and what? 2. So let's see. So you can see the output is even giving us like 3 by 3 array, which that is not even close to what we want. You understand? So let's look at the third person, Hazan Kolaole. 1, 3, 1, 3. That's it. That's correct. I understand. So Hazan got it correct. So to index 8, 9, and 6, 4, we look at the row where this particular value is. So 8 and 6, right? They are in row 1, 6 is in row 2. So to get the row 1 and row 2, we have to say 1, then colon, then 3, because if we use 2 here to just give us, it will exclude this particular number, right? So we have to put 3 here, so to give us the the second row and the third row. Why the colon? We have this 8 is in the first column, and 9 and 4 is in the third column. So we still do the same thing, 1 and 3. All right. So come here and put 1 and 3. So we're going to get this. Are we following? I really want us to understand this. I really want us to understand this. So I'm going to give us another example, another one. So let's assume we want to index let's say want to index 4, 3, 2 and 3, 2, 6. Want to index 4, 3, 2 and 3, 2, 6. What code are we going to write? Want to index 4, 3, 2 and 3, 2, 6. Okay, let's quickly look at that. So as I said, 2 with 2. All right, this one, I think everybody is getting it. So let's print it out. So you can see the output here, 4, 3, 2, 3, 2, 6. Very, very straightforward. Understand? So I believe we've all understood how to index from a two-dimensional array. The reason why I'm paying more attention, I'm giving laying emphasis on this is because when we enter three-dimensional array and you don't understand how to index two-dimensional array, it's going to even become more complex. You understand? So to understand how to index two-dimensional array, you need to understand how to index one dimension first, right? Before then moving to the two dimensions. So let's now move on to the next one, which is the 3, slicing from a three-dimensional array. So let's just quickly create a 3 array. Then I'll come here and say np.array. Then we'll have this 5. Let's put this one down. So let's come here, create 2D, 3, 4, 5, 6, right? 2, 3, 5, 7, and let's create one more, and then say 1, 9, 7, 4. Right, so that is the first one. So we'll create another one. Remember what I said, a three-dimensional array is basically two-dimensional arrays, right, in clusters. So come here. All right, so this is our three-dimensional array. So can someone just at the top of your head just tell me the shape of this array? At the top of your head, what's the shape of this array? At the top of your head. Let me see how well we understand three-dimensional arrays. Beautiful. That is beautiful. From Hassan Dolapo, got it. Tijani. Yes. The answer is 2 by 3 by 4 because we have what two two-dimensional. We have two-dimensional arrays in two places, and inside that two-dimensional array, we have the shape of that two-dimensional array is 3 by 4. That is basically that you just deduce the shape, right? So that is it for 3 dimensions. So how do we slice this? So slicing this array is can take extra step. So in this case, we are going to put 3 numbers here. Let's say 1, 2, 1. So in this case, we are going to get this particular number here. So the same logic applies to the first one. So the one in this case refers to the okay, the one in this case now refers to our first index, right? The 2 here refers to the second row on the the third row on our second 2D array, and then our 1 refers to the first column. So this, okay, let me actually break it down. Let's go back to this dimensional array so we can follow just understand. So remember, in this 2D array we have let's say we want to slice 4. So call me and say 0 and 1. So we're going to get 4, right? So this 4 here is on the 0 index and on the first column, right? So this is how you slice your 2D array. So bring that same idea now to this 3D array, right? But now you have to add an extra number. You have to add an extra number at the beginning to specify the particular 2D array you are referring to. Is it the first one or the second one, right? If it's the first one, we're going to come here and put 0. So in this case, we're going to be referring to this first 2D array here, right? And this 2 here will be referring to the second row, the third row, which is this row here, and the first column, which is 9, right? So you come here and you see the value, the output is 9. Understand? So that is why I need you to understand this two-dimensional array here. And to understand two-dimensional, you need to understand one-dimensional array. So you bring the idea, you start the idea of these different dimensions, so you'll be able to understand how to slice from this dimension. So in this case, we have 3 numbers here, right? For two-dimensional arrays, you always have 2 numbers, and for your one-dimensional array, you have 1 number. So this is when you actually want to slice just one element. Understand? When you want to slice one element for 1D array, you have just one number to refer to that element. For 2D array, you have 2 numbers to give you the precise location of that element in the row and column. By the first number, we refer to the row, while the second number will refer to the column. While for your 3D array, you have 3 numbers referring to the 3 dimensions, right? So basically, the first number here refers to the first 2D stack, or this is the first dimension here, right? There is the first 2D array in your 3D. Then the second and third number refers to that particular 2D array. It refers to the position of the number at the row and at the column, right? So if you're lost at this point, that means you've not understood what we've been talking since, right? I took my time to explain the 1D slicing, 2D slicing. Now 3D slicing is still the same thing, just that we're introducing a new value here that will point to the particular array, right? If it is this first array, it will be 0. If it is the second array, it will be 1. Okay, let's assume we have a third 2D array here, 2D stack. Let's come here and add another one. If we add it to the stack, we now have 3 dimension. Sorry, this shape will now be 3 by 3 by 4. So if we want to refer to a particular value in this 3D in this three-dimensional array, we now have to pinpoint the particular 2D array that we're referring to. Let's say it is this third one that we want to bring out a value from. Let's say it is 7. We want to index 7. Understand? We want to index. Before I even move, let me just see, or let me just know if some of us are following. Okay, if you want to index 7 from this particular array, what do you think would be the code to use if you want to index 7? I just want to test us to know if we actually understand slicing from a three-dimensional array. Oh, someone has gotten it already, sir. Tolulope. Miracle, cold pressures. Like, we are getting it, sir. We are actually getting it. You understand? So that is the correct answer. 2 by 1 by 1. So if I run this, I'm going to get 7 because 7 is in the third stack, which is the third two-dimensional array in your in your 3D array. And the 7 now is in the first row and the first column of that third stack. So you just have to think of it that way. I know it can be confusing and all of that, but that is how you understand it best, right? So let's just move forward. We don't have much time. So the same logic applies when you want to like slice not just a number, but let's say you want to slice a portion of it. So if I want to slice, let's say from that 3D stack, I want to slice 1 to 3, and let's say 0 to let's say 3 2, right? Okay, this one doesn't have 1 3. You stopped at 2, so I'll say 0 to 2. You see that I'm basically slicing this particular portion of this second stack, right? So if I want to slice, let's say, the second array in this my 2D array, how do you think I would do that? I want to slice just this particular one. I want to bring it out from this entire stack. What code will I use based on all these things we're talking about? What code will I use if I want to bring this out from this 3D array? Someone said 1. Okay. Can you see it? Simple. So if I ask you to, from this 3D array, extract this particular array, I can just come here and say array 3D1 and assign it to a new array. And I can say new array. I can see it now. And if I print out my new array, it will give me this particular array. And it is now a two-dimensional array, right? You can see 3 by 4. So you can see how like easy it is to just play around with all these things, right? So let's try to just understand how to work with these things. I understand that it can be complex when it enters the three-dimensional array, but trust me, it is easy once you practice. As you continually practice, you're going to find it easy to work with, right? So that is it for slicing of arrays, and I believe we've all understood it, right? If you don't, you can as well always go back to the video. And if there's a specific thing you want to know, you can ask your question at the end of the lecture. All right. So let's move on. Let's move forward. So what we have here on what we have next here is these are just examples of all these things that we've talked about here. So we're going to be looking at the basic operations in NumPy. Basic operations in NumPy. So you can, I told you that NumPy is used for performing numerical computation operation. Understand, right? So in NumPy, we are in NumPy, basic operations on array are essential for performing numerical computation efficiently. So we're going to look at them. We have element-wise operations. These are the categories. We have array broadcasting, and we have okay, this is just a concept, basically vectorization. So we're going to look at these two, element-wise operations and array broadcasting, and I'm going to explain what vectorization is, right? So what are element-wise operations? Let's quickly see. Okay, remember we did types of operations in Python. That is the arithmetic, the comparison, and all of that, the logic and the rest. So when we come to NumPy array, we can actually perform arithmetic operations on our arrays. Yes, we can perform arithmetic operations on our array. We can perform addition, we can perform subtraction, we can perform multiplication, we can perform division on arrays elements wise. And I need you to pay attention to this element wise, right? I'm going to explain that. So this means that the corresponding elements of the array are operated on pairwise. We also have what we call universal functions. Let me highlight that. U-funcs. So U-funcs are very um, handful. They are handful when performing operations in NumPy. So these are specialized functions, just know they are functions provided by NumPy for element-wise operation. They offer optimized performance and convenience when working with array. So I'm basically just going to see what we are talking about here, all these things that has been said here. What does it even mean at all? Right. So when we talk about element-wise operation, let's go back to our sheets. All right, so let me create two array one, so np.array, 4, 5, 6, 7, and array two, three, two. All right, so I'm going to name this array two. So I've created two created arrays. So array one and array two, these are two one-dimensional arrays, right? So basically, if you want to perform element-wise performing, so we can perform addition, we can perform subtraction, we can perform division, and we can also perform multiplication, right? So how do we do that? So we have our array one and our array two, and I want to add these two arrays, this 4, 5, 6, 7, to this 2, 3, 2, 3, 2, 2. How do you do that? Very straightforward. By the same way you would add 2 plus 2, or the same way you add two variables. NumPy allows you to do that same thing on your array. And the reason why it is called element-wise is because it performs the operation element-wise. So it adds 4 to 2, adds 5 to 3, adds 6 to 2, and adds 7 to 2. Right? So you're going to get a new array that would be equivalent to the addition of each of the elements here. That is why we call it element-wise. So if I come here and say array 1 plus array 2, I'm going to get this as the output. So I'm going to get 6, 4 plus 2 is 6, 5 plus 3 is 8. 6 plus 2 is 8. 7 plus 2 is 9. So this is the output. So this is basically what element-wise operation is. So this is addition. Addition. So just go back to the arithmetic operation we did the other time. So if you say array 1 minus array 2, this is subtraction. We're going to get this. 4 minus 2 is what? 2. 5 minus 3 is what? 2. So that you just have it like that to perform the operation element-wise. Understand? So if I come here and say array 1 times array 2, that is multiplication. If I run this, you see it gives us the same thing. I come here and say array 1 divided by array 2 division. You see that it's divides it for, so giving us the same thing. So let's even check if the other arithmetic operation that we looked at would also work on them. Array 2, you can see we're having this for floor division, and we have array 1 modulo array 2. You can see that we have this. So this is basically the same concept with arithmetic operation. It's just that it is now being performed on NumPy array elements wise. You understand? Elements wise. So let's just check something. If I remove one number here, you see that it's giving us an error. So there's something that we need to understand first. We're going to explain some, broadcasting later on. But whenever you are trying to perform this kind of element-wise operation on your array, just ensure that the two arrays you're multiplying, they are of the same dimension. Understand? Make sure that they are of the same dimension, right? If not, your operation would throw an error, right? Because there's nothing for 7 to multiply with or divide with or add to here. It is just standing alone. So you make sure that you have something here, right? So you have that, and it will give you your output. So I hope that is clear. So this is basically what element-wise operation means in NumPy. So you can actually have the same thing for two-dimensional arrays. So if I come here and make this two-dimensional, right, 3, 4, 2, 1, and come here, make it 6, 8, 4, 2. You see we have the same thing, right? But the output will now be in 2 dimensions, right? So it's going to perform it on each array, like on each element in both the row and column. So it will multiply 3 by 6, to multiply 4 by 8, it multiplies 6 by 2. So if you look at the corresponding element in the first array and the corresponding element in the second array and perform that operation on both of them, right? So this is how you perform element-wise operations on array. Are we still following? Please, can you confirm in the group chat if everybody if you're all following? All right. Nicodemus, I don't understand your question. If possible, you can rephrase or something. Okay, so that's it for element-wise operation. You can do the same thing for 3D arrays. Just know that you're going to get 3-dimensional output here. You understand? So let's look at what we have here. So we have what we call U funcs. universal functions, right? So this is basically um functions that you can use in performing these arithmetic operations, right? So we have them here. We have add, we have subtract, we have multiply, we have divide. So instead of doing this particular method, I can use universal functions using ufuncs. It's called ufuncs or universal functions. So keep that in mind, very important. Ufuncs, universal function, to perform element wise operations. So now if I want to perform addition, instead of doing this its manual way, I can just come here and say think np, yeah, np dot add, and say array 1 comma array 2. So I'm going to get these outputs. I'll come here and say np dot subtract array 1 and array 2. I'll get this, right? You can see subtraction there and all of that. I can do the same thing for divide, multiply, array 1 and array 2. I can do the same thing for divide, right? Array 1 and array 2. So this is basically what ufuncs are, universal functions. So these are the functions: np.add, np.subtract, np.multiply, np.divide. These are the things that you can use to just perform this element-wise operation, right? So there's a distinction I want to point out. np.add is not equal to, right? Is not equal to np.sum. So we have another function called np.sum. This is an aggregation function. We're going to look at it later on, but it is not the same thing to np.add. np.add is a universal function. np.sum is an aggregation function, right? So I can ask this question. Just make sure you understand this. So if I come here and say np.sum array 1 and array 2, I'm going to get this output. Okay, sorry. np.sum doesn't perform operation on two outputs, on two arrays rather. It performs on one array. So that is for np.add. So np.sum is aggregation function. It adds all the value in that array together to one and give you the output, basically. So that is what it does. So we're going to talk about aggregation function either today or tomorrow. So I just wanted you to know that distinction so you're not confuse np.add to np.sum. All right. So this is basically what universal functions are, right? So these are you perform your np.floor division. I don't think there is a function for that. I don't think there is a function for floor division, but you can as well check it. So let's quickly check together. Print dir np np dot there's floor division. Okay, you can see here. Okay, there's actually floor divide here. You can see floor divide here. So let's look for modulos. I think this should be it. I don't know. It's not something that is used commonly, so I'm not really sure. So I think you can just come here and say np dot floor divide array 1 and array 2, right? So you can see the output here. I don't know if that mode is for modulo, but let's just try np.mod array 2. All right, so basically, it should be, let's see, shift tab. Oh, okay, you can see now this is a universal function, ufunc, and what it does is it returns the element-wise remainder of the division. So this is the modulus operation. So if you're confused, you can always just press your shift and tab, and then you can read the documentation for that particular function. So this is how you perform universal functions or element-wise operations on your NumPy array. You can do it for any dimension, right? Just know that it's going to give the output is going to give you be in that same dimension because it's an element-wise operation. Do you understand that? All right, so let's just move on. Let's move on with what we have. Is everyone following up to now? Is everyone following? And can you hear me very well and see my screen? All right, all right. Okay, so we're going to proceed from here. We're going to quickly look at broadcasting in NumPy. So after this, I think we'll just let's see what we have remaining. We'll look at array broadcasting, and then we're going to then start with array manipulation, right? So if we can finish that today, then we'll just keep it, we'll just postpone it to tomorrow because I don't want this class to extend so much. I want us to wrap up with NumPy this week, right? So next week we're going to start with pandas, and that's when we're going to start manipulating data and using data. All right. So let's just quickly. So let's look at broadcasting. What is broadcasting, right? Broadcasting is a powerful mechanism in NumPy. Like it's very useful in NumPy, right? It allows arrays with different shapes to be combined in an arithmetic operation. Remember, we've done the universal function, element-wise operation, and all of that, right? Now we're going to see how you can use broadcasting, what broadcasting mean when performing this arithmetic operation. So what it does is that it automatically aligns arrays with compatible shapes and sizes, enabling operations to be performed efficiently. So what exactly are all this English saying? So let's just go back to our this thing notebook. So now, let's assume we have, let's bring one of this array here. Okay. Let's assume we have an array here. I'm going to start with a one-dimensional array so it will be easier to understand. Let's assume we have this array. This is a one-dimensional array. I want to multiply it with an integer. An integer here is, let's say num. I want to multiply everything with 5. So this is a scalar. If you remember your mathematics class, you know what scalars are. Scalars are just they don't have direction basically. So they're in mathematics they are just numbers basically. So this array is a vector, right? But we're not going to use that terminology. We'll use an array here. So we have this one-dimensional 1D array, right? So we have this our our scalar here. I want to multiply it. I want to perform operation on this particular array here. So what does broadcasting do? So now broadcasting picks this particular 5 and broadcast it across these arrays. So what you're going to have here now, you're going to have the array 1 is what? 4, 5, 6, 7 against what? 5, 5, 5, 5. So this is what broadcasting is. So this is basically what broadcasting is here. So this 5 that is here, it will be stretched to align with the shape of this particular vector. So the operation can be performed on it. So in this case, we want to perform maybe division. I can come and say array 1, or let's say addition, plus 5. If I run this, you see what I'm going to get? I'm going to get 9 because 4 plus 5 is what? 9. 5 plus 5 is what? 10. 6 plus 5. So what happened is that initially we had only one number here, and we want to add 5 to this array. NumPy will broadcast this scalar to fit the dimension of this one. And I know you might be thinking now, I thought you told us that if the array is, where do we have it? If the array is not aligned, it's going to give us an error. No. The difference between this was what I showed us before. Let's see, let me pick this. The difference between this and this, let's say I bring 2 here. The difference between this and this is that they are of the same dimension. This array 1 here is 1 dimension, right? I'll come here and say 1D, and array 2 is what? 1D. And I come here and say array 1 plus array 2. It's going to give me an error. Why? Like, you might be getting confused here. Broadcasting works when the other number or the other array is of a lower dimension and not in the same dimension. So this scalar is actually a lower dimension to this one-dimensional array. You understand? So when I start giving examples with 2 and 3 dimensional array, you understand. But this scalar here is of a lower dimension. So if I come here and put it in, let's say, an array here, it's going to give us, let's bring this. I'm going to put num here. It's going to give us an error. You understand? It's going to give us an error basically. So, okay, sorry, let me put this in a bracket. Let's say 2. It's going to give us an error because this dimension now is 1 dimension, right? And this one is 1 dimension, but the size is different. So as long as they're in the same dimension, broadcasting won't work. So for broadcasting to work, it has to be a scalar. A scalar is like just a number, basically. So you can have a scalar to be like an integer or maybe a single value in an array or whatever, right? So I'm not going to explain what a scalar is. So if you run that, it's going to broadcast this particular number to fit the particular numbers that we have, the particular number of elements we have in the other array. So now, now this whole thing might be now kind of confusing you and all of that, but it's fine. This is NumPy. NumPy has to do with numbers, and numbers can be abstract a lot of times. So I just need you to just take your time, understand. Just try to pick out some things, understand. Just pay attention, and this kind of concept needs your attention to the maximum. If you don't give that maximum attention, you're going to miss some things, and those things that you miss will make you not to understand subsequent things I'll be explaining. So And let me just that is basically how to follow up with this. There are some things I'll be explaining. You don't really need to pay full attention, but you still be getting it regardless, right? But this one is an abstract concept. These are mathematical concepts. So you need attention, you need to give your full attention to pick up what I'm trying to convey. So this is basically what it is. So now let me give you another example that would further explain the broadcasting rule to you. So let's use adding, okay, let me bring out this array because of time. This is a two-dimensional array here, right? Now I have array 2. This is going to be a one-dimensional array. Now, if I come here and say array 1 plus array 2, I'm going to get an output. Even though these two different arrays are not the same dimension, this array 1 is of 2 dimension. Why this array 2 is of 1 dimension. But what happened here? This was possible because of broadcasting, right? Someone said they can't see my screen. Is this just them or is it everybody? All right, great. So what happened here was that, let me just illustrate it. We had the array 1 to be 4, 5, 6, 7, right? And we come here and we have 3, 4, 2, 1. So your array 2 is what? 4, 5, 6, 7. So for this operation to happen, because we want to add this array 2 to array 1, for it to happen, NumPy broadcast this element to fit the shape of this other element, right? So we're now going to, what happens behind the scene is that this particular element will be broadcasted down to become 4, 5, 6, 7. So it will now be represented like in the same dimension as the array 1 that we have here. So the operation will now be performed element-wise. Understand? So this particular element here will be duplicated to fit the shape of this one. You understand? So make sure that when you are trying to do this thing, the other array is of a lower dimension than the second array. So if you want to use three-dimensional array, the same logic applies. Three-dimensional array and what? A lower dimension. So in this case, now let's say we have a scalar, right? A scalar here. You see, we are actually going to have the same broadcasting. What will happen here is that 4 will be broadcasted to fit this particular shape. So we will have 4, 4, 4, 4, 4, 4, right? So that is what happens. That is basically what broadcasting is. Understand? So the same thing applies in 3 dimensions. So let's say we have 3-dimensional array here. We have 3 and this and that. We have this, we have 1 and this and that, right? So this is a 3-dimensional array. So if we multiply it by 4, okay, sorry, I'm not putting the other bracket there. If you multiply this by 4, you're going to see the output here. So let's just quickly see if it's correct. So 4 plus 4 is what? 8. 4 plus 5 is what? 9. 4 plus 1 here is what? 5. You can see 4 was added to everything in this 3D array, right? And the way it was done, it was broadcasted to fit the same dimension. So the element-wise operation will be possible. Because what you want to do here is to perform element-wise operation. And to perform the element-wise operation, you have to have the same the same dimension. You have to have the same number of elements and the same dimension. So when this thing happens, NumPy will automatically broadcast that value to fit or to align with your other array. You understand? So in this case, we have just four. Let's say we have 4, 3, 4, 3, right? It's going to broadcast it, and we're going to have 4, 3, 4, 3 broadcasted to become 3 dimension, right? So you have 4, 3, 4, 3, 4, 3, 4, 3. That is your 2D, and you now come again and have 4, 3, 4, 3, and 4, 3, 4, 3. So that is basically what happens. So let's say we have 2 dimensions here. We have 4, 3, 4, 3, and what? 7, 5, 6, 3. The same thing will happen. This 2 dimension will be duplicated to become the same shape with these 3 dimensions. So this 4, 3, 4, 3 now, when the elemental operation is going to be broadcasted basically, and it should be something like this: 4, 3, 4, 3, 7, 5, 6, 3 would be replicated, so that when you're multiplying it, you won't get an error. So the same thing applies, and you get your value. You get the output in the same way you would get when you are multiplying the same shape of the array, of an array, of 2 arrays basically. So that is it for broadcasting. So it's what happens. Like, you don't see it, right? But it's actually how how NumPy enables all this multiplication, addition, and element-wise operation to be possible, right? To be possible. So I hope that is clear enough. I hope that is clear enough. We need to move on. We need to move forward so we can cover more ground. Don't worry, we'll be rounding up very soon. We're not going to spend so much time today. So once we finish vectorization, we are going to call it a day, and tomorrow we'll continue from array manipulation and then look at aggregation function, right? So what exactly is vectorization? So just as we are rounding up, just note your question. I'm not going to be taking too much questions, just about 5 questions or so. So vectorization refers to the process of applying operations to entire arrays instead of looping over individual elements. It leverages the underlying, okay, these are just grammars, right? Now, what vectorization means is that the operation that you will normally perform with for loop is sped up, or it is made faster using NumPy. That's what vectorization is. Vectorization is a concept in computer science where the processing happens in parallel instead of loop. Instead of waiting for one to finish before doing the other one, everything just happens at once. That is what makes NumPy very fast and efficient. Remember in the introductory class of NumPy, I told us that NumPy, somewhere here, that NumPy is very, very fast, right? NumPy array is fast. It's faster than your normal Python list. So when you are using NumPy array, when you are performing numerical operation on them, you see very, very fast output, or you will get very fast output. So we're going to demonstrate it so you understand exactly what vectorization is. All right. So now I'm going to show you 2 things. I'm going to give you an example, right, to illustrate the vectorization concept. So let me just quickly copy this. So vectorization is not something that you'll be doing, but it's just a concept in NumPy. You understand? It's just something you need to understand, right? It's how NumPy functions. So you don't expect to to learn a particular code on vectorization and all of that. No, it's just a concept, a conceptual something that you need to understand to help you appreciate NumPy better, right? So let's initialize two variables. We have array 1 and array 2. So just ignore this. We're going to look at how we can do this tomorrow. So this is basically a way to generate random arrays. So if you come and say large array 1, you see that we have, if I say shape, so we have 10, how many? We have, I think, 1 million. Yeah, 1 million elements. You understand? So what we want to do now, we want to multiply this array 1 and array 2. And we're going to do it using two methods. We're going to do it using NumPy, and we're going to use it using normal Python loop. And we'll see which one is faster or which one is the fastest, right? So let's just quickly show. This just demonstrate. This is basically just to demonstrate vectorization. All right. So let's quickly look at that. So this is the traditional. So because of time, I'll just copy this. So this is the traditional. If you're not using NumPy, this is the traditional way we're going to do that. We're basically going to initialize a variable that would take in the results, right? And then we're going to loop over the length of the array, that is 1 million times. And for each of the step, we're going to add that particular value of array 1 to the value of array 2. And the results, we're not going to add it to this particular loop or this particular result here, right? So we're going to run this and see how long it takes to run, right? So I'm going to run this. You can see that it's still running and it's done, right? But let me increase it so that you notice the difference. So you can see that it's still running, 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 it's still running. So you can see how long it is taking. You can see it has stopped running, right? So let me print out finished. Running. You can see how long it is taking using our for loop. Right, so just finish running. So now let's use NumPy method. So the way we would use NumPy is basically just to say large array, your element-wise operation, right? Plus large array 2. So I come and say results and come and say print so you can see how fast it was. Like before I even blink, it has finished running. Understand? If I let me run this one again to show you. I think there's a way I can you can see how long it took for the particular operation to run using for loop. And now we are going to use the normal NumPy. You can see in a second, even like millisecond, it has finished running. You can see the difference now between using NumPy vectorization and using for loop, right? So NumPy is 30 times, or I don't know the specific number, but it is way more efficient in using NumPy to perform numerical operation than using your normal Python for loop and all of that. You understand? So always make sure that you are using arrays instead of list, and make sure that you are using NumPy universal functions instead of the normal for loop that you have, or that you would have in Python. So let's see how we can just display this so you would understand it better. Let me use time. I think there's a magic command called time it. Use this for okay. So I have to import time 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 it. I'm looking for a way to just make this thing to help you understand it better, so you can see the time difference between the two operations. I think it's time or time it. All right, so but basically this is just to show you what vectorization is. You can see the difference in the speed, right? The execution speed. So I think maybe tomorrow we're going to just I don't know why this particular time it's command is not working. Right? But that's just by the way, it's not necessary. All right. So that's vectorization for you, right? That's vectorization. It speeds up the operation or the numerical operation you perform, right, using NumPy instead of using your normal for loop. So that's going to be it for today. We've actually looked at a few things. We've looked at indexing your and slicing your array, indexing one-dimensional array, indexing and slicing two-dimensional arrays, indexing and slicing three-dimensional arrays. So we then moved on to looking at what element-wise operation are and how to perform them. Looked at the different element-wise operation, addition, subtraction, and note all these element-wise operation that we have here. They use vectorization, right? They all use vectorization in performing the operation or in carrying out this operation. So that is what makes it very fast. So we have addition, subtraction, multiplication, division, floor division, modulus. It should be modulus. And then we have universal functions. We have the np.add, np.subtract, np.multiply, and all of that, right? So we looked at how to perform the elemental operation. So we also looked at broadcasting in NumPy. Looked at broadcasting, what broadcasting is, the concept, and how it is being done. So this is a concept in NumPy that stretches the dimension of a particular value to fit that which is being applied, or it is being multiplied or added to, or whatever operation it is you're carrying. So that is what broadcasting is. We showed us how broadcasting can be done or is done on one-dimensional arrays, two-dimensional arrays, and as well as three-dimensional arrays. And also we concluded with vectorization, showing you how efficient NumPy operations are as compared to for loops, right? So if you are not using this NumPy, the other option is use a for loop, which is very slow. And when you're performing a lot of operation, right, a huge operation, a large operation, is going to take a lot of time. For vectorization, speeds it up by performing the process in parallel, right? So you saw the difference in execution. So let's assume you want to perform, let's say 100 million you want to perform this on 100 million elements, this thing is going to take forever, basically. But the vectorization can take like 2, 3, 4 seconds just to perform it. So that should show you the power of NumPy. So yeah, that is it for today. We are going to stop here and continue from there tomorrow. So as we all know, this is time for questions. So if you have a question, please just indicate by raising your hand, and I'm going to call you up. All right, Sunday Alpha, please ask your question.
Good evening, sir. Good evening, sir.
Sunday Alpha.
Hello, I've unmuted myself. I want to be sure if you can hear me, sir. Good evening,
Okay,
sir.
yeah, I can hear you. I can hear you. Go on.
And good evening, everyone. Thank you so much. We appreciate you for all the lectures. I don't know whether I should be asking this question now, but I just want to ask. Can one import multiple libraries at a time and then call them forth when you want to put them to use? Like you import NumPy, you import Panda, just consecutively like that, and then later call them for to use when you want to use them. And that operation be
Yeah,
performed.
yeah, sure. Thing is that as we are proceeding to other libraries, you're going to see them in use. For now, it's just one library we've introduced, so we cannot really demonstrate that. So once we introduce you to the other libraries, you're going to see that yeah, you can import as many libraries as you can, and then proceed to using everything in the subsequent cells. So I believe that explains that.
All right, thank you, sir.
All right. Any other question? Any other question? Does anybody has question today? Is it a good thing or a bad thing? It's a good thing if we all understand it, or I think it's not really a good thing if we don't really know the question to ask because we don't really understand it. Which one of them? So I actually wanted to close us on time today. I don't like overwhelming people. I like us to take it bit by bit. Although if we think that some particular points we need to cover a lot, but today's I think NumPy is a bit abstract, right? So these are the things that I don't want to overwhelm you. Just look at some part of it and then you go back to it and look at it and understand it before we move on to the final part in tomorrow's class. And next week we're going to start with pandas. So that is when you're now going to start. We're going to be working with data sets. You're going to be importing data sets and all of that. So it will get very interesting from there, trust me. So Nicodemus, you're asking how can we leverage vectorization and broadcasting in a real-world data science program? So that I told us that broadcasting and vectorization, they are concepts. They are not like something that they are not things that you write code that like it's not like creating an array or performing all these operations. They are just concepts that are the underlying concept in NumPy. So whenever you are using all these NumPy functions and all of that, automatically broadcasting and vectorization will be taking place even without you knowing. So you can be using NumPy, but you don't really know what is happening. Understand? So these are just concepts. Like these are core concepts in NumPy that you need to understand as a data scientist. So vectorization is one of them. You can't really code vectorization. There's nothing like coding vectorization. You just use the NumPy functions and which implement this vectorization already. So and broadcasting as well. So once you are multiplying a particular array with another scalar or a lower dimensional array, automatically NumPy will broadcast it for you. So you don't need to write a code to broadcast it yourself. So this is basically what it is. So there is nothing like um I don't know, but the way to leverage it is to use this NumPy function or to use NumPy when performing large operations, right? Especially when you're machine learning automatically uses vectorization for you, so you don't even need to stress yourself when you're performing machine learning operation, which uses a lot of data and perform a lot of operation. It uses vectorization, so it's something you just need to know as a data scientist. The concept you need to know. I understand. All right. So since we don't really have question, we're going to be calling it a day. We looked at just few things today. Please go back and go back to the video. The video will be released. It will be made available today, hopefully, or tomorrow. So you can go and okay, someone wants to ask a question. Sulaiman Yusuf. All right, so go ahead and ask your question, Sulaiman. You're on mute now. Hello, Sulaiman. We can't hear you.
Say,
Hello. Hello, Sulaiman. Please, if you are here, can you speak up? All right. Okay. Nicodemus, please go ahead and ask your question.
Right. Good evening, sir.
Yeah, good evening.
My question is, I want to know these assignments we're doing, are they being recorded?
Of course.
Okay, sir. Like what I'm suggesting is you should create a sheet where we can maybe once in a while view our scores as they are being recorded from week to week, so that we know our performance level and see how we can improve on that. Because we're just writing and you just grade and send back to our email. But is there any way you can do it in a collective something where we can just go there and follow up this week? This is what you have scored, and so that we can be seeing the percentages.
Yeah. Your overall score week by week is on the Google Classroom. You can view everything there. Um, I think you just go to assignment and I think you click on your grades. You see everything. You see your week one grade, your week two grade, your week three grade, your week four. As you are submitting, you'll be seeing everything. So everything is already organized for you in Google Classroom. So it should be easy for you to navigate. So maybe you can ask your class rep after this to show you how to locate it, but it's there already for you.
Yes, sir. Thank you.
All right. Okay, Ozioma, ask your question, please. You're on mute now.
Hello, sir. Can you hear me? Good evening, sir.
Yeah, I can hear you. Good evening.
Okay, my question is still on the assignment. Sorry to bring the use of on the grading aspects. I don't know if it's me that is not submitting right, but I keep getting 0/10. It was this last one I got one, and from when you were explaining the assignment before the start of the class, now I followed up and I discovered I got almost everything, but on the grading, I'm still having 1/10.
If you had 1/10 or so, it means you either didn't submit the assignment or you submitted the assignment, but it was an empty assignment. You didn't submit the one that had the answers in it. So it should either be or it should be either either of these options. So there's
All
no
right.
way I would go through the assignment and then give you one without no. But let
Okay.
me know your class. Just send me a DM after. Let me know your class, and I'll go through.
All
I'll
right,
see what
sir.
we can do in that.
Okay. Thank you, sir.
All right. Okay, so we'll be calling it a day now. Please, go over this video once it is released, and try to use the book, the material that I posted in the Google Classroom, the Python data science material. It will help you a lot. It will help you a lot. So you can, okay, someone has a question. Okay, yeah, please go on. You're on mute, Wasiu. Opeyemi, Wasiu. Hello. You raised your hand,
Hello,
Opeyemi. Yeah, go
yeah, good
ahead.
evening, sir.
Yeah, good evening.
Yes, my question is also on an assignment. The last assignment that I did, the grade have not been uploaded.
Which assignment
I
was
don't
that?
know, maybe I'm doing the last week assignment that I did.
Week three.
Yes.
Yeah, I said it earlier that some persons have not received their grade yet. So by the end of today, you should receive your grade.
All right. Okay, sir. Thank you, sir.
All right.
Yeah, thank you.
Okay. All right. So in the absence of, all right, Kabiru. Kabiru, you are raising your hand. You can go ahead and ask your question. You're on mute now, Kabiru. Kabiru, please go ahead and ask your question. You're on mute. Hello, Kabiru. You raised your hand. Okay. Um, by beating, I don't know. Please, you're on mute. Ask your question.
Hello, sir.
Guys,
Good evening.
yeah, good evening.
Can you hear me?
Yeah, I can hear you.
Sir, I'm a Kabiru Sabu, sir. That
Yeah,
three
I can hear
assignment you
you.
gave it that 3 weeks, sir. I cannot do anyone because I'm too busy, sir. Can you give me any opportunity to do it, sir, or not? Please.
Kabiru, um, we have a deadline, and we've been using that deadline for the past 3 weeks. So if you are unable to do within that deadline, that means you forfeited the assignment for that week. All right, so you just try as much as you can to meet up with the next assignment. So there are reasons why we do this, and we need everyone to fall in alignment, right? So if you, I believe everyone here has things they are doing, right? So just try as much as you can
Okay, sir.
to integrate the program so that it can so you can be able to find out time to just do this assignment because I don't know, you just have to, right, to move along with
Okay,
the
thank you, sir.
class. So yeah,
Okay.
there's nothing I
Okay,
can do at
thank you,
this
sir.
point. Just ensure that subsequent assignment you try to meet up with the deadline. All right. All right. Amatri, I don't know how to pronounce the name. I'm so sorry. But you're on mute. You can ask your question. So is there another question? Is there another question? Let's call it a day if there is none. Is there another question? Someone is saying, sir, is it possible we use a practical question for the examples? That way it will be easier for us to apply when solving assignment question. What do you mean by a practical question? Please, if you are the one that asked the question, you can just come up and expatiate. What do you mean by practical question?
Maybe I've asked the question before. Wouldn't
Um, I told you already that this NumPy is abstract, like we have in mathematics. So you just learn the concepts and all of that we are doing today. And when we start applying it subsequently, you'll see the usefulness of it. So it was the same way you were learning F string formatting initially. You didn't really understand how it is being used at that point. But as we proceeded, you can see how it is being used and the importance of the of formatting your string, right? So it's the same thing with NumPy. NumPy is like a fundamental concept or fundamental library in Python that is applied when doing your data science task like machine learning and analysis and all of that. So we're going to see them. So I just need you to understand what we are doing at this point. Just understand it as it is coming. You understand? So and I believe this was explanatory enough for you to get, right? I okay, you are raising your hand. Alabisi, yeah, go on and speak, please. Alabisi, you raise your hand. You can. Do you want to say something? Okay, so I believe I've answered your question. So if there's anything you are finding difficult to understand, that is why there's always room for questions. So you ask your questions, and we try our best to answer those questions. All right. So I believe that is it. Nicodemus, you still have your hands up. All right. You're going to be the last person before we close for the day.
All right, sorry for coming back again, sir. When we this is the confusion I have when we're applying for this program. This particular aspect we applied was actually data science and data analytics. But when you started the uh, this thing, when you started this program to mentor us on this program, you were being specific on that. I mean, on data science, that we may not particularly be looking at data analytics to analysis. So I don't know whether they have separated classes for this because when we're applying, the option was data science and data analytics. I don't know what happened that we're just looking at only data science.
By now, all these questions, all this should not really be an issue again. We've already addressed all of this. Right, I've said it several times during introductory classes, during the onboarding that is data science we are doing. Even the first class we had, I took us through the data science life cycle, and this is what we'll be doing, showing us the tools we'll be using and all of that. So this is week 4 already, and we we've gone like we are we've gone so far. So you don't expect us to still separate into a different track again, right? Basically, this is that data science program. Everything we'll be doing evolves around that, and we'll be using Python as a tool for this particular track. So the data analysis is embedded in it, right? When we start doing pandas, we are going to be doing a bit of data analytics and all of that, right? So that is where that comes in. But the having data analytics separately as a track is not part of was not part of the plan or is not part of the curriculum. So so that is it for that. So this is a data science program from start to finish. All right, so we'll be calling it a day. Thank you very much, everyone, for your time, for your attention, and for for your questions. So as usual, leave just let us know what you picked up today on the group chats, and yeah, enjoy your weekend and enjoy the rest of your day as well. And see you tomorrow. Thank you.